Good morning, lovely 13s. Right, buddies, today we are continuing our amazing adventure in mechanics. Last lesson you showed you were really good at drawing free body diagrams, doing an F-net equation, a balance equation, knowing that F-net equals ma, and pretty much you showed that you were able to do kind of any questions where you had to break stuff down into components. So I hope that that was good, because today we're going to go to the very next level, which is inclined planes as your title. So please put the title inclined planes for me, please. Cool. And the one thing that's different about this to last time is, you know how we broke stuff down into horizontal and vertical? That's usually a really sensible thing to do horizontal and vertical, but often the acceleration in a question may not be in a horizontal or vertical direction. So for instance, I don't even know, if you were skiing, I want to go skiing. If you were skiing, the gravity would bring your acceleration to be down the slope. It wouldn't be like down vertically, it would be down the slope. And so it's actually in a direction that is parallel to the slope. So you wouldn't want to resolve stuff in horizontal and vertical because that's not where your motion is. And that's what we're going to do today. We're going to resolve stuff in different directions, in the x direction and the y direction, actually. So how exciting. Let's do it. Cool. So your very first question here says this. It's a block of mass 10 kilograms. Ooh, let's get the highlighter going, actually. It says, a block of mass 10 kilograms slides down a smooth slope. What does smooth mean again? That's right. Smooth means there's no friction at all. Cool. Angled at 15 degrees to horizontal. Cool. Now part A, question A, just says this. Draw a force diagram to show all of the forces acting on the block. Now, they called it a force diagram, but that's because they're not like cool physicists like we are. We don't actually call it a force diagram. What do we call it again? That's right, a free body diagram. So that's what we're going to do, my buddies. Cool. So here, let's do it. Okay. First things first, it's just a slope. Just draw it kind of generically. You don't have to worry about it being 15 degrees. So I'm going to draw myself like a 45-degree slope like that. Boom, there's our lovely slope. And I'm just drawing it like a triangle for the block to be on. So it's a right angle, obviously. And it said that this was 15 degrees. Cool. What we're going to find is there's a block on it. So the block is drawn just like that. The block weighs 10 kilograms. I'm going to draw it bigger. It's going to be too hard to squeeze the kg in there. I'm going to draw my block a bit bigger. Boosh. There we go. 10 kg, like a boss. And that's that. Cool. Next question is, what forces are acting upon it? Like, what would this block experience? It's on this smooth slope. What's it going to experience? Like, what force is acting on it? Well, for sure, it's got a weight, right? And weight, if you're talking about weight, which way does weight always act? That's it, vertically downward, okay? So it doesn't make any difference that it's on a slope. Weight, W, is going to be acting vertically downward. Now the thing is, though, with that, is there any other forces? Is there another force acting on it? Well, yeah, there needs to be, because since it's on this plane, since it's on like a slope here, it's not going to actually fly through the slope. The slope is going to prevent it from flying through. So what there is, my lovelies, is what we call, from last year and from last lesson, there's a normal contact force. Now that's going to act out this way, perpendicularly to the surface, and it's called R. Because it's a normal contact force, it's also called the normal reaction force, and that's why it's an R. And so it acts perpendicularly off the slope because it's not going to be able to fly through the slope, so it acts in a direction that's perpendicular to the slope. Cool. Next question. Is there any forces that are popping down, for instance, that way? Is there something driving it down that way? Well, no, because actually there's nothing pulling it. Is there anything up this way? Anything resisting it going down the slope? Nope, because there's also nothing pulling it back. No frictions or anything like that. The final question I've got for you is it moving? Is it accelerating? Well, yeah, it will be. If it's a smooth slope, it's going to absolutely be like slicking its way down the slope. It's going to be going downward through the slope. So it does have an acceleration, and you draw that, don't forget, with an arrow with two lines in it, two of them for acceleration, one of them for velocity, and label that A, and it's going to accelerate down the slope. Cool? Well, there it is, buddies. You've just done it. Now, here you go. The thing that's new and exciting about this is now the acceleration isn't horizontal or vertical, so we're not going to be able to write down like hor and vert like we did last time. What we're going to have to do is we're going to have to introduce a new direction system. And here's what I'd suggest. Can you see that A is down the slope? We should draw our acceleration, or we should draw our components then, so that they're down the slope too, to match with A. So here we go, you ready? Go like this. R is already perpendicular. Here, maybe I'll just do this. I got a better idea. I'm going to show you this way. So introduce a coordinate system, that's what I'm going to do, that's easier. Go like this, put a little arrow there for X. Go like this, little arrow there for Y, and what you've just said is X, down the slope, is the positive direction. Y, off the slope, is the positive Y direction, so that's what we've got there. Cool. Now look at your forces. R is already in the Y direction, so we don't need to do anything to it. But if you look at W, can you see it's vertical? That means it's neither in the X direction nor the Y. So what we do is we break it down so that it is. Always start by drawing the one opposite to R first, and then go that way as well. And now you've got two directions. You broke your W into two components. WY that way, WX this way. Now, we don't know the angle between them, but I'm going to give you a tip that you can always use. If you always start by making R opposite to W, then see that 15 degrees? It's going to go in there. Now, I'm going to show you why, but you don't have to show this every question. So I'll say it one more time. If you always draw it the same way as me, so you always draw it so that the WY part is opposite to R, then you can just nick this angle and put it in there. Okay? Now, I know you won't be satisfied with that, so I'm going to prove to you why. Here it is proved why, okay? I'm just going to redraw these, so this is optional. I'm going to erase it in a moment. This is not part of the question. I'm going to show you why that's 15. Here's why. W is vertical down, okay? So I'm just going to redraw the vector over here, because as you know, you can draw vectors where you like, okay? They're not linked to a position, unless they're a position vector. And there you go. That means WY is like here. Okay, and WX is like there because they're parallel and perpendicular. There's WY, there's WX, and there's W. So I've just drawn that bottom triangle down here near the angle. Okay, and this is it. I can show you why just now. See how that's 15? That means this makes 90 between those two because parallel and perpendicular are perpendicular to one another. So if that's 15, then this is going to be 90 less 15, so 65 degrees. Okay, so that angle is 65 to make it all the way to, to make, what am I doing? To make it 90, aren't I? It's 90 take 15, so 90, 80, 75, sorry. 75 degrees, yeah, because they have to equal 90 altogether, right? But similarly, horizontal to vertical, which is what this gray angle is also 90 degrees. So if that's 90 degrees and this part's 75, to get the rest of the way to 90 is 15. And there you go, that shows it, because that 15 is that 15. Okay? Now, I don't think that you're going to want to do that over and over and over and over again, so take my word for it, that's how it is. As long as you start drawing the WY first, you get the same answer as me, but that's the Y, okay? That's the why that is the case. Cool? I'm going to delete this off to make my picture pretty again. So here we go, bang, 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 bang. So now that I proved that, push, 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 there we go, beautiful. Okay. And that's it. We finished part A, so that's brilliant. Okay, part B says calculate the magnitude of the normal reaction of the slope on the block. What variable is that? That's right, it's R. So here's what you're going to do for B. You know, wanted to get R, right? Well, check this majestic thing out. We're going to go back into our regular old way of working. So we're going to decide a direction to look at. R is in the Y direction, you see, because that's where it is there. So you can write this. You're going to write wider. You don't even have to say which way is positive, because since you drew this, you've already said that upward is positive, off the plane is positive. So here you go. You ready? F net, the balance of forces, is going to equal, in this instance, it's R, because that's the upward one, take WY. There's no other forces that are in the Y direction because our blue W switched for the red WY and the red WX. Cool? Now you say to yourself next, is it accelerating? Well, it is, but not in the Y direction. It's not leaving the surface, which would mean the Y direction. It's staying on the surface. So the acceleration in the Y direction is nothing. So if F net equals ma, and a is 0, F net is 0. So you're going to get 0 equals r take, and instead of wy is cosine. Like, see, this is a right angle triangle too, and wy is cosine. So this is going to be w cos 15. Cool? W is mg though, so 0 equals r take mg, m is 10, g is 9.8, and that's cos 15. After the substitution step, there's never, ever, ever any more marks, so skip steps all you like. Use your calculator, which is amazing. So it's going to be 98 cos 15, which I have is 94.7. So 94.7 newtons, like a boss. Cool? Same exact thing as we did last time, but it just happens to be that we're doing x and y direction as opposed to up and down direction, horizontal and vertical. And the final question, find the acceleration. Boom. Look at this. Say to yourself, well, what direction is acceleration in? Hopefully you can see straight away, it's the x direction, right? Acceleration is down the slope, and the down the slope direction is the x direction. So what do you write? Actually, do it without me. You can do it. Push pause. Go. Okay, and you're back. So just to make sure you did get it, so you're in the x direction, as we just said, x direction, balance of forces, F net, equals, what you've got in the x is going to be wx. There's no other force in the x, so that's that. F net, though, it is accelerating this time, so we'll swap it for ma. Wx is going to be w sine this time, sine 15. Okay, m is 10, so it's going to be 10. We don't know what a is. W is mg, 10, 9.8, sine 15. Now, this is a neat one because actually, look, the 10's common to both sides. But again, it doesn't matter if you didn't do that. There's no marks for that. Which means at the end of the day, acceleration is just 9.8 sine 15, 9.8 sine 15, which is 2.54 meters per second squared. Now that seems reasonable to me from a physics standpoint, just because, you know, free fall, like regular falling, is 9.8 meters per second squared. So if it's at a relatively low angle, 15 degrees, 2.54 is reasonable, because it's nowhere near 9.8, which is the max. Cool beans? Right. Should we go way, way, way harder now? Yeah, we should. Okay. Now this, I would say, is hard exam-y level question, okay? But you do get them. It's really good. You never got one like this in year 12, but I enjoy these. I find them a bit like a puzzle, and so they're really neat. Anyway, let's read through. It says, a particle of mass m is pushed up a smooth slope by a force of magnitude 5g, okay? So we're pushing it up the slope with a force of 5 times that of the acceleration of gravity, okay? Or the acceleration due to gravity. So that's, it's weird it's given it in g, but this is kind of what it will be like at university. If you take, say, well, physics certainly, but also engineering, you'll often do stuff in general like this, which is why it's cool. At an angle of 60 degrees to the slope, causing the particle to accelerate up the slope. So it's important that it's up, and it's at 0.5 meters per second squared. Now it says, show that the mass of the particle is this. Okay, so there we go. Oh, another pro tip as well. Did you see how I just highlighted and have written all over everything? These questions can sometimes be a paragraph long, so it's nice to go through and highlight stuff so you'll have easy access to it. Cool. Right, so what's the first thing we have to do in every single mechanics question? That's right, draw a picture, my buddy. So let's draw a picture together. So it's already kind of there to help us, but let's do it anyway. Nice big slope. I'm going to try to draw it big, so I think this might be complicated. So nice big slope like this. Lovely, lovely, lovely. We know for sure that this is 30 degrees because it says that. They drew the particle as a circle, so they drew it as a circle because it was a particle, but I like everything to be a square unless you're using like geometry properties of it, so which you don't even have to do at A level, but like for instance, if you had a ball rolling down a hill, you draw that as a circle, but anything that's just an item, I always draw as a square. It says it has a mass. Its mass is m, but we don't know that mass, and that's brilliant. Cool. What forces are acting on it? Well, there's the given force, there's the 5g force, and it's at a 60 degrees to the slope. I'm going to draw it like this. So here we go. Let's draw it a bit like this. Ooh, drat. I'm going to draw better than that. Just like this. Pointed at that corner. Now, it doesn't matter if it's not exactly at that corner. You could have drawn it on the floor. You could have drawn it on the top of a circle like they just did there. Provided that you got your arrow in the right direction, it doesn't make any difference. Now, this force was 5G. Okay, I'm going to ditch the newtons because I think it's just going to confuse things. And here we go. Straight away, it says it's at 60 degrees to the slope. So here we go. Dash, 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 dash. Dash, 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 dash. And the 60 degrees is going to be there. Okay? It says it's 60 degrees to the slope, and I know what you're thinking. You're like, the slope is on the floor, though. But you could imagine having just drawn this triangle at the bottom of the square, and then it would have matched, right? Because the slope is parallel to that. Cool beans? Cool beans, okay. Just because you guys are still beginnery at this, I'm going to call this f equals, actually. You can skip this step in the future, though, which means that this would be fy, and that would be fx, okay? Cool? Any other forces acting on it? Well, yeah, it's in real life, and it's on Earth. It's got a weight. Downward. Weight. Any other force on it? Well, it's not flying through the surface, so there's going to be a normal contact force this way that prevents that. It's a reaction force, R. Is there any acceleration? Yeah, there is. Now, you could be pushing the thing up, but it's coming backwards. That would be like you trying to push a car up a hill. That's not going to happen. The car would crush you, absolutely. But this is a littler object, I presume. And so that means, my lovelies, that it has an acceleration. They actually are pushing it hard enough for it to go up the hill. A is equal to 0.5 meters per second squared. Well, guess what? You've nearly done it now, guys. Make your direction convention. I'm going to use the same as last time. X is going to be up the hill, and Y is going to be off the hill, okay, off the slope. And that's what you've got. Anything else need a component? Well, yeah, W does, because it's not in the X and Y direction. So we'll have this as WY, and we'll have this as WX. And because I was sick and drew it that way, you can cheat like me. That's 30 degrees. Beautiful. 30 degrees between those for the same reason as last time, that proof that we did last time. Cool. And we're after the mass of the particle. Cool beans. What do you want to do, buddies? What should we do? Oh my word, what on earth do we do? Well, you start at a direction, okay? Acceleration is given. Do you want to start in the horizontal direction and see how we go? Okay, yeah, because acceleration is given. They've probably given me that for a reason. Who knows? Let's try. So here we go. Exter. And first step in these equations, what's that every time? That's it, yeah, every time it's F net equation. Okay, the balance of forces. F net equals, and what's going up the hill? Well, only just Fx. R's not anything to do with the hill. It's off the hill, so it's not up the hill. And then you have Wx as well. That's down the hill. So it's minus Wx, and that's what you got. Cool? Is it accelerating? Well, yeah. So we're going to swap F net out for Ma. Fx, let's get this in terms of f, because we don't know anything about fx. So fx is going to be f cos 60. And in case you're still not quite sure on that, it's cosine. Cos 60 is fx over f, which means that it's f cos 60. That's it. Wx, we're going to go take away, and that's going to be w, but this time sine 30. Cool beans? All right, we want f, so we're doing good. We've got our things on track here. It seems like to me that we're doing well. So yeah, let's do it. Ma, so let's do it. M is, oh, it's our unknown, sorry. And A is 0.5. So it's M times 0.5 equals F. F was 5G, so it's 5G cos 60. And W is mg, right? So this is going to be mg sine 30. Okay, now here's what I would do if I was you. I'd have a little peek at the answer that I'm supposed to get here in blue, and I'm going to say to myself, how's it going? Is it going okay, or is it going a bit rubbish? I think it's going okay, to be honest, because there's m's and there's g's in my equation only, which means that I'm probably on the right track here, to be honest. I think I'm on the right track. So that's brilliant. Cool. So let's just start tidying things out. And because I'm trying to get an exact answer, I'm going to go for surds if I'm given the option. So let's see if I am given the option. Okay. So the left side, 0.5m. this side, I'm going to type close 60 into my calculator and see what comes out. I think it's 0.5. It is 0.5. So here's what you're going to get. You're going to get 0.5 from that times 5. 0.5 times 5 is 2.5 g. And here we go. On this one here, we have mg sine 30. Sine 30 is going to be 0.5 as well because it's the opposite of the other one. And yeah, it is as well. So this is going to be, take away 0.5 mg. Okay, I just put the sine 30 is 0.5. Okay, it's a bit horrible. I don't like the decimal points, and it is an equation. This is maths after all, and physics. So I'm going to double both sides to get rid of the 0.5s. Don't care for them. So it's going to be m equals 5g take mg. And some of you might have spotted the answer already. What am I trying to get again? I'm trying to get m, right? So let's put the m's on one side. M plus mg equals 5g. And what do we do to solve it? I'll give you a hint. It starts in f and ends in actorize. Yeah, that's it. We're going to factorize it out. So let's do it, buddies. M, open bracket, 1 plus g, right? Equals 5g. Now just divide both sides, buddies. Just divide them out and see what you get. Oh, there was space, so I'm going to erase the arrow. I'm going to make it really pretty. Okay. Just divide both sides and you've got it then. M equals 5g over 1 plus g. Like an absolute beast, like a boss. Now I know that g is 9.8, but again, in this question it had a g in the answer, so he didn't happen to have to swap it out. I hope that's okay. That's an example of a hard one. So if you had your head around it, then that's really good. And if you have your head around it, it's also really good because that's why my method is so good. So follow my method, my lovelies. No matter how you learned it last year, follow this method. It makes them all easy. And that's it. Cool. So yeah, it's oh, not terribly short video actually, but shorter video. Here's what I'm gonna get you guys to do. Page 98, question 1 to 8, but do a mix, okay? Because some of the first questions on this, some of the first questions here are not too bad, okay? Like question 1 and 2 aren't super hard. Do make maybe question 1 because it's a good practice for you to make sure you've got your head around the basics. But yeah, they're gonna take 10 minutes each kind of thing. So if you want to like do question like 5, 6, 7, that would be brilliant. Or like 1 and 3 and 8 or something. Do you see what I mean? Do a mix that lets you sample all of the different difficulties of this. Got it? If you have any questions, as like I said last time, just talk to me on the Google chat and we will we'll get you sorted, okay? So just shout out, speak to me, it'll be cool. And that's it from me for this time. So see you later. See you next time, buddies. Bye, buddies.